just like a little recap, whoopsie daisies, of what we have sort of been chatting about with equations. We're going to do some nice easy ones, and then we'll get stuck into the slightly meatier ones. Remember, what's really important with equations is that you're using your inverse operation, so your opposite operation to what the equation originally said. And the reason we do this is because we want to keep that equation balanced, essentially. We want to keep the left-hand side equal to the right-hand side. And so if we're going to start adding or subtracting or multiplying or dividing something on one side, we need to do the same thing on the other side. So if we have a look at this first question, we've got x plus 6 equals minus 3. Now, some of these equations you'll be able to sort of look at and you'll say, okay, well, I know what that answer is, and that's that. And that's absolutely fine for the easier ones. But when we start to get to more complicated equations, we need to understand how to work through these. So if we have a look at our inverse operations, and this is what's really important here with equations, the first thing I want to do is I want to see, okay, well, where is my x that I'm trying to solve for? And how am I going to essentially get that x alone? So what I see is that 6 is being added to x. And so using my inverse operations, what I actually want to do is I want to subtract 6 on both sides. Now, you don't have to write this step down if you don't want to. If you're happy that you can do this in your head, that's absolutely fine. But we want to subtract 6, because by subtracting 6, if we have a look at what's going on the left here, a positive 6 minus 6 actually gives me 0. And so what I've done is I've isolated that x variable and gotten to solve for x. And I've also kept my equation balanced, because not only have I subtracted 6 on the left, I've also subtracted it on the right. So I haven't changed the meaning of this equation. I've kept it balanced, and I can solve for x. So once we've got x entirely by itself, we've got our answer. So minus 3 minus 6 is minus 9. And I see some of those answers coming in the chat. Well done. All right. Remember, what's really cool about equations is that you can check yourself. Now, if you want to check yourself, all you need to do is substitute back into your original equation. So you will take your answer of x equals minus 9 and you'll sub it in. So in place of x, we put in minus 9 plus 6 equals negative 3. And what you're checking for is that the left-hand side is equal to the right-hand side of your equation. So very quickly, you can do this on a calculator as well if you don't want to waste time. Minus 9 plus 6 is negative 3. And negative 3 is in fact equal to negative 3. That is true. And so your answer for x is correct. Okay.
So I just see a lot of hands. Just Sam, can I take some of the questions?
Cool. Yeah.
Okay, so Tero, we're gonna go with you. Tero, would you like to unmute on your side?
Yes. Hello. How did you get the double x on the left-hand side?
Where's the double x? Sorry.
Double x plus 6 minus 6.
Yeah, plus 6 minus 6.
Okay, so what I needed to do there was what I wanted to do was I essentially wanted to get rid of that plus 6. And the only way I can get rid of a plus 6 is to minus 6. So this minus 6 is sort of what I am adding into the equation in order to solve for x.
Okay, so essentially, if we had the same number, let's say if it was, for example, an x plus another number, a 9. If you want to get rid of that, then you have to minus it by the same number.
Exactly. Yeah.
Okay. All right, great. Okay, I'll explain it to her. Thank you.
Cool.
Thanks.
Okay, so we're gonna take, if that's okay with you, Wayden has his hands up.
Cool.
I cannot unmute you on your side. I'm not quite sure what's going on Wayden's side. Wayden, if you can hear me, is it okay if you can log out and then in again? Can you hear me?
There we go. I think we might have got it.
Ah, did we get it?
Wayden?
I can't see the unmuting button on my side.
Oh, no, I thought I could see it. Oh.
Wayden, if you can hear us, can you please type something on the chat? And if you can please log out and then in again. And then like this, we can be able to talk to each other. because right now we can't, okay? So I'm just gonna put that on the chat like this, you can see. Teacher Sam, you can continue.
Awesome. Okay, guys, so let's have a look at question 2 over here. So question 2, what we need to be mindful of is the fact that I've got an x term on both sides of my equation. So my equation is 3x minus 10 equals 2x plus 10. All right, now, whenever I've got x's on both sides of the equation, what I want to try and do is get, oh, that's supposed to be a star, I'm sorry, is get the x's to the left. Now I'm saying the left because generally we'll always have our answers x equals some value and x is generally always on the left. It's not wrong to have the x's on the right. And so if that's what you want to do, that's fine. But if we just always say get the x's to the left, then we can always follow the same procedure. So I essentially want to try and get all of those x terms onto the left. What that then means is that I want to get the constants, so the numbers, to the right. Okay. And to do this, we need to do our inverse operations again. Alrighty. Again, you might be able to look at this and say, I know exactly what the answer is, and that's absolutely fine. But like I said, as these get a little bit harder, we need to be able to do our inverse operations. Now, if you can do these in multiple steps, that's also absolutely fine. I'm going to do this slowly, step by step, so that everyone's clear on what's happening. So the first thing I'm going to do, and maybe this will help a little bit with our inverse operations, the first thing that I'm going to do is I'm going to try and put this positive 2x onto the left-hand side. Now, the only way for me to do that is to use my inverse operations. So if it was positive 2x, my inverse operation would be to subtract 2x. But what I do to the right-hand side, I also need to do to the left-hand side. What that results in is my equation becoming 3x minus 2x minus 10 is equal to, now that 2x minus 2x on the right, they actually cancel each other out because 2x minus 2x is 0. So I'm actually just left with a positive 10 on the right. What I then go and do, as we've already said, I also want to get my constants all onto the right-hand side. Now I need to somehow get this negative 10 onto the right. And to do that, I'm going to use my inverse operation. So I'm going to add 10 to both sides. And so what I end up with is then 3x minus 2x is equal to 10 plus 10. Now you've got all your x terms on the left, all of your constants on the right, and that then means that you can go and find your answer for x. Now remember, x's are all like terms, the constants are all like terms, and so 3x minus 2x is then x. If you want to put the 1 there, that's absolutely fine. And 10 plus 10 is 20. And so what we've got here is that x is equal to 20. And like I say, you can always go check your answer by substituting back in and making sure that the left is equal to the right-hand side.
Okay, just now I have some questions for you, Mike.
Oh.
I want to ask you questions. So wait, then I'm going to start with you. Wait, please unmute on the small little button so you can talk to us. The one that you see on your computer. Do you see anything? Anything that pops up on your screen? You just have to click on it. Okay, Wayden, I hope you will succeed, but let me know if you need help. Ah, there we go. Hi, Wayden.
Hello.
Evening. Do you have a question?
Not yet.
Okay.
Okay, Wayden, so we're gonna mute you for now. Okay, so I hope you did try the sum here. I hope you did get it right and mark it. Okay.
Okay.
Okay, so Ntabi saying, I'm gonna come to you. Hi.
Hi.
Evening.
How did you get the positive 10
Okay,
from
so
the 10?
all right, so remember, if I want to, and I'm just going to do it in another color here. if I want to essentially take that -10 and put it onto the other side of my equal sign, the only way for me to do that is using inverse operations or the opposite operation. So if it was -10, I have to add 10 on both sides to move it over. And so -10 plus 10, if we just sort of put that on the side, gives me 0. And so what it's doing is it's moving over to the right-hand side of my equation. So that's where I got that plus 10 from. Does that make sense?
Yes, ma'am.
Good. Well done.
Okay, so I'm saying I hope that was okay. Tero, I'm on your side, girl. Try and unmute on your side so you can ask your question.
Can you please repeat again how you got the positive 10 and the minus 2x?
Okay, so what I'm trying to do is I'm trying to get all of my x terms to one side and then all of my constants to the other side. So again, I'm just going to change my color here. If we go back to the original equation, essentially what that means is I want to get this positive 2x onto the left, which is what I've said over here in my little notes. And then what I want to do is get that -10 to the right. So get my constants on the right. The only way for me to move things across an equal sign is to do the opposite operation. So this 2x, even though there's no sign there, is actually a plus 2x. So in order to move it across, I have to minus 2x, which is what I did over here. And the same thing for the -10. The only way for me to move it over the equal sign is to do the opposite. The opposite of minus is then plus 10. So that's why I have plus 10 in order to move it over. And so that's why I end up with 10 plus 10 on the right.
Great.
I get it now.
Cool.
Yeah. I also get it. So
Cool. Nice.
Nice, then, Tero. Hope you understood. Okay, so I have another hand. So I'm
Cool. You
just,
guys are welcome to try this in the meantime. Question 3.
yes, I know 100 is done and 100 didn't have any questions. So 100, I hope you are trying this one. We are all yours.
Afternoon, ma'am.
Hi.
Ma'am, I just got here, so I have no clue what we're doing.
Okay, so we are doing solving equations. So what we're doing is we're solving for x. If you've missed the others, don't stress too much. Everything's recorded, and so you can go back and watch the start of the lesson on the website, okay?
Yes, ma'am.
Cool, so try this one for me. Okay, guys, so what we have here is 9x plus 3 equals 7x plus 13. So we sort of want to do the same thing as what we were doing in question 2. And if you need a quick refresher of what we need to do, is we want to get our x terms to the left. Oops, I'm just going to put an L, and then we want to get the constants to the right. And the only way we can do that is to use inverse operations. Alrighty. Again, your working out might look a little bit different to what mine looks like, and that's absolutely fine. I'm going very much step by step. If you can do this a little bit faster, that's absolutely fine. Okay. So remember, the goal is I want to get the 7x over onto the left, and the only way I can do that is inverse operations. And I also want to get this plus 3, which is the constant, over to the right-hand side. Right, so let's see how we would do that. If we go back and look at that 7x, if I use inverse operations, I need to remember that that 7x was originally a plus. So the opposite of that is to minus 7x. But if I'm going to do that on the right, I also need to do that on the left-hand side. So that then leaves me with an equation of 9x minus 7x plus 3 is equal to 13. And remember, the 7x falls away because positive 7x minus 7x, they actually become 0. So we've moved it over the equals. The next thing I want to do is deal with that plus 3. So if it was originally plus 3, if I now want to move it, I have to subtract 3. But if I'm going to do that on the left, I have to do that on the right-hand side as well. And so my equation is now 9x minus 7x is equal to 13 minus 3. Now, guys, obviously, if you see 9x minus 7x and you're happy to write that as 2x, go for it. You don't have to wait until later on to get to that answer. That's fine. You can start to simplify as you go. I'm just sort of going step by step here. So 9x minus 7x is 2x. Oh, that's a weird looking x. 2x. And then 13 minus 3 we know is 10. Now, guys, remember, the whole point of an equation is to solve for x. So I want to get that x completely by itself, which means that I actually also need to go and look at how do I get rid of this 2 over here. Now, what this goes back to is sort of our algebra way back in the beginning of the year. We need to remember that this is saying 2 times x. That 2 is the coefficient, so there is a operation of multiplication between the 2 and the x. And so now again, we say, okay, well, if I want to get rid of the 2, what is the opposite of multiplication? Well, the opposite of multiplication is division. So if I divide the left-hand side by 2, I must also divide the right-hand side by 2. And what that leaves me with is a 2 divided by 2 on the left, which is actually just 1. So if you want to have 1x, that's absolutely fine. Or you can just have x is equal to, and 10 divided by 2 is 5. And so we get that x is equal to 5. And really importantly, guys, we always want to get x alone. That is the point of solving our equation. So we don't want any other coefficient other than a positive 1 there. Okay, now I'm seeing a lot of questions to re-explain and all the rest of this, but you guys, I hope, are listening. Look through carefully what I've done and then listen to each other's questions that we're about to get now, and hopefully your question might be answered, okay?
Okay, guys, so with this question, let's get some hands up if you don't understand so that you can ask your question. And then I can unmute you. Okay, Andre, I'll start with you, okay? So you can unmute on your side.
Can you guys hear me?
Yes, we can hear you.
Okay, so by the answer, it's 1x equals 5.
Yeah.
Is that a mistake, or I don't know, because you're supposed to get the x alone on the bottom.
So 1x is the same as x. So if you leave the 1 there, that's absolutely fine, but you can write it as just x equals 5.
Oh,
okay. So either one's absolutely fine.
Okay, thank you.
Pleasure.
Ghost one. It's a ghost one, guys.
Yeah.
Okay, so we're gonna go to Lebohang. Lebohang, we are all yours. Just click on your side and you can ask a question. Can you manage, Lebohang? Okay, while Lebohang is still trying there, Uratile, I'm on you. Can you manage, Uratile? Hi, hi. You can talk, Uratile.
How are you?
We're good. Ask the question.
So like you must just okay.
We can hear you, Ratile. Just continue asking your question. Where are you getting stuck?
Okay, so the main point is that we must the x must just be like on its own.
Exactly. Well done.
Okay.
Okay, so that is exactly it. We always want x completely alone.
Okay, so I'm gonna go to Chibuzo. Chibuzo, we are all yours. Click on your side.
Hello.
Hi.
I just wanted to ask, how did the 2x is equals to 10 divided by 2? How did mem divided by 2? Because question 2, it was 1x, if I'm not mistaken. 1x is equals to 20. So how did mem divide the 2 in question 3.
Okay, so let's try do this so we can see question 2 as well. I don't know if it might be a bit small, but let's have a look here. Right, so in question 2, what was different was that exactly as you've said, it was a 1x, okay? So that was a 1x. Now, yes, that is a coefficient, but would you agree with me that even if I go and divide the 1x by 1 and the 20 by 1, I still get x equals 20. So that 1 in front of the x isn't going to change the value. However, when I get to something like question 3, because the coefficient, so that number in front of the x isn't 1, I now need to go and do the inverse, because if I divide something by 2, I'm definitely going to change the value. And so as we were saying now, we always want to get x alone. Now, x currently in this step is not alone. X still has been multiplied by 2. And so I need to get rid of that multiplication by 2 by dividing by 2 in order to just get x by itself.
Okay, thank you, ma'am.
Okay, cool.
Hey, Chibuza. Okay, now Lutando, it's now your turn.
Why is it on mute?
There we go.
Hello, ma'am.
Evening.
Hi.
I just wanted to ask from the second step. I didn't quite understand from the second step.
This step over here.
Yes, ma'am.
Okay, so do you understand why I've got 9x minus 7x?
Yes, ma'am.
Okay, cool. So basically the second step is now saying, and I'm just going to take my scribbles off again here. If I now have already moved the 7x to the left, I now also need to move this plus 3 to the right. And in order to do that, I have to subtract 3 on both sides. So it's the same thing as what I was doing with the minus 7x using inverse operations. I'm just now doing it to the constant, the number. So if I want to take that plus 3 over to the right, then I need to say minus 3 on both sides of my equation, and that will move it over to the right-hand side of my equation.
Okay, thank you, ma'am.
Okay, cool.
Hey guys, I hope that some of you already, your questions have been answered, because we are all listening. So if your question has been answered, please lower your hand. But if not, keep your hand up. But I'm not sure if teacher Sam is still giving us time to ask questions, because we need to.
So we do need to move on. So what I'm going to do is, you can see question 4 and question 5 over there. If you don't have questions and you're feeling comfortable, please try question 4 and question 5 while I hear the other questions, and then we'll quickly go through those ones before we move on. Okay, because this is actually sort of revision of what we've already done, and so I don't want to spend too much time on this.
Seho, we are all yours, girl.
How did you get the 10 and how did you divide it?
No, not the 10. So, ma'am, sorry. So
No?
you got the solve for x as a 5, right? So I just want to understand the rule there, where it says 2x, which is, I understand it's 2 times x, right? So I want to understand the rule that makes us divide the 2 by the 2.
Okay, so it's the same rule as what we were using earlier, sort of like what you had said earlier, where we do the opposites. If it had been a plus 3, we now minus 3. Because it was a times 2, we now divide by 2. So we use the opposite operation.
All right. Thank you.
Pleasure.
Pleasure. Okay, June, I'm on your case, June. So the last one. June, would you like to speak to us? You can unmute yourself. There we go. Hi. Hi.
Okay, ma'am, I'm lost. I don't understand.
I need more. Where are you lost? Which step?
Yeah, at 9x minus 7x plus 3 equals to 13.
Okay, so do you understand why I said 9x minus 7x?
Ma'am?
Do you understand why I said 9x minus 7x? Do you understand why I did the minus 7x?
Yes.
Okay, so the minus 3 is the same thing. I want to take this plus 3 over here and I want to move it over onto the right-hand side. And the only way for me to do that is to do the opposite of what it originally was. So it originally was +3. So I have to now -3 in order to move it over.
Okay.
Okay, and then from there, it's just simplifying. 9x and 7x are like terms, so I can subtract them. And that gave me this 2x over here. And 13 minus 3 gave me that 10. And then as I've just explained, we needed to divide by 2 to get the x alone.
Okay.
Okay.
I get it now.
Okay, we're going to keep practicing this, guys.
Yeah, we're gonna keep on it. So Zinhle has added an additional question. Z, I'm on your case. Just unmute on your side.
Oh, hello, ma'am.
Hi.
Ma'am, I really don't understand this the second step. So I wanted to ask if you add your like terms, for example, 9x plus 7x.
Minus 7x.
Yes.
Yeah.
Oh, and then you say 13 minus 3.
Yeah.
Oh, okay. I really wanted to understand because I really didn't get it.
Yeah, so all we're doing is exactly as you say, we're adding and subtracting our like terms according to what the question tells me to do. Good.
Okay. Thank you.
Later.
Right, Zinhle. Okay, so Thandi, I hope that you will be our last one. But all you remember, you have 2 questions to do. So please do try it, okay? So Thandi, we are all yours, girl. Let's go.
Hello. Can you hear me?
Hi.
Yes.
Okay. I'm stuck by question 4.
Okay, cool. So let's have a look at question. Oh, let's have a look at question 4 and let's see if we can get you unstuck here. All right, guys. So question 4, we've got negative 3x plus 2 minus x equals minus 3x minus 8 minus 2x. Now, you've got lots of different choices here. My advice is the second you see an equation where you can see that there are like terms on like either side of the equation. So for example, if we go and have a look at the left-hand side here, I can see that the minus x and the minus 3x are like terms. And if we go and look at the right-hand side, I can see that minus 2x and minus 3x are like terms. Just to make your life easier, I would simplify. You don't have to, it's not necessary. You will get exactly the same answer, but I'm just going to simplify this for myself. So minus 3x minus x is negative 4x. And then I've got that plus 2 is equal to minus 3x minus 2x is minus 5x. And then I've got that constant negative 8. All that does is it neatens up your equation. If you don't want to do that, like I say, it's absolutely fine. You will get exactly the same answer. What this now does for me is it lets me see a little bit clearly the fact that this negative 5x needs to move over to the left-hand side. And remember, in order to do that, I need to do the opposite. So I must plus 5x. And then I can also see that the plus 2 on the left needs to move over to the right. And in order to do that, I must subtract 2 on both sides. So what I have here is then, and this is, if you would like to, you're welcome to write it out like this, minus 4x plus 5x on the left, and then on the right, minus 8 minus 2. If you still need to be writing your step of minus 4x minus 5x plus 2 is equal to minus 8, and then only bring your minus 2 over, that's absolutely fine. But you're welcome to jump straight to the step here that I've put the star at. Okay, so as we've discussed, we now see that we've got some like terms here. So negative 4x plus 5x is then just x, and minus 8 minus another 2 is minus 10. Now, this is what we were talking about earlier. Yes, there is that ghost 1 in front of the x, but 1 isn't going to change the value. And so as long as we've got that positive 1 there and not another number, we can stop there. And so we've got that x alone. And so x is equal to negative 10. And remember your check if you want to double check your answer. All righty. So that's question 4. If we, and I'll give you a second if you need to screenshot it. If we have a look then at question 5 is a little trickier, but remember the goal is to get x alone. Now my x term is actually already on the left-hand side. So the only thing I actually want to do here is take this -2 and bring it over to the right. Now we know to do that, I have to subtract 2. I have to do the opposite. And so what I end up with is -8x is equal to 18 minus 2. So I've done my inverse operation. We know that 18 minus 2, we know that 18 minus 2 is 16. So I've got -8x equals 16. And then guys, this is very similar to what we had going on here in question 3, because remember, I don't have that x alone. So what I want to do now is I want to divide by a -8, because I also don't want that negative. I wanted just x. I need to divide both sides by -8. Now, if you are in doubt about this, you can definitely use a calculator to double check yourself. That -8 divided by -8, we know is going to leave me with that 1x or just x. And then be careful. If you've got a positive divided by a negative, you know you're going to get a negative. And then 16 divided by 8 is 2. So here, my answer is x equals -2. Okay, so I saw some of those correct answers coming through. Well done, guys. You did really nicely with those 2 questions. Very proud of that. Well done.
I have one question. Tandi,
Cool.
we are all yours.
Hello.
Hi.
I got stuck by question 4.
Okay.
I don't understand. How did you get the -5x?
Okay, so I got the -5x by seeing that on the right-hand side, the -3x and the -2x were like terms. So what I did, just to make my life easier, I just subtracted.
Oh.
Okay. If you didn't do it like that, that's absolutely fine.
It's correct. Thank you.
Okay.
Well done. We're proud of you. Okay. This class, you guys are genius. I'm proud of every one of you. Let's do this. Let's go.
Okay, guys. So we've done.
I have a question. Sorry.
Okay. No. So we've done half an hour. So just while we're listening to the questions, if you just want to get up, stretch, move your body, and then we're going to carry on after we've heard the questions. All right.
Yes, let's stretch, guys. It's going to help you. Your brain is going to function. Tandi.
Hi, Tandi.
Quick question. By the second step on number 4, right? Is it the positive plus the negative equals to something, because there it ended up being a -4 instead of a +4.
Okay, I'm sorry, say that again. So the second step where I've got the star there.
No, by yes, no.
Okay. No.
The top, yeah, that's the one on top.
This one.
Yeah,
okay.
Yes, that one.
Okay.
So is it how you got to the -4? Is it like a negative per minus a negative, or negative times a negative equals 2? Oh, okay.
Yes. Okay, so what I did there was very similar to what I did on the other side. I've got the -3x minus x. So all I was doing was adding and subtracting my like terms.
Oh, okay.
And guys, you don't have to do it like that. But honestly, if you can simplify, it means that you can decrease the number of terms you're working with, and that makes your life easier. Okay.
Yeah.
Cool.
Okay, so we're gonna move on to Lungile. Lungile, we are all yours. Shoot your question.
Hi, ma'am.
Hi.
Ma'am, I was stuck in question 3. I just wanted to ask that where do you get the 2 and the 10? Because I think that you get it for the 2, you get it from the 9 minus 7, if I'm not mistaken.
Good, well done, yes.
And the 10 is 13 minus 3.
Excellent, well done. That's exactly where they came from.
Okay, thank you, ma'am.
Pleasure.
Yeah, you guys are doing great, Charlotte. I am all yours. Let's ask away. You raise your hand, eh, Charlotte? You can go to your side. Hi.
There you go.
Hello, ma'am. Can you hear me?
Yes,
we can hear you.
Ma'am, I'm stuck on question 4, ma'am.
Okay, where are you stuck?
Ma'am, so this negative 4x plus 5, negative 4x plus 2.
Yeah.
You first collected the like terms from the question.
Exactly.
Also negative 5, but it's not.
So those are all from the like terms. So those like terms here added together to give me negative 4x. And then on the right-hand side, the like terms of negative 3 and negative 2, when I subtract them, gave me negative 5x. So I just sort of added my like terms so that I knew what I was working with.
Oh, thank you, ma'am.
Sure.
Great. Okay, Grandma and Maseko. I'll call you Maseko because I cannot pronounce that other one. Okay, we are all yours, Maseko. Hi. You can ask your question.
Hi.
Hi.
Ma'am, I was stuck on question 4. How did you get the minus 4?
Okay, so like
on
I
the
just
second line.
Right, so like I just said, it's just come from my like terms. So all it is the minus 3x minus x. When I subtract them, give me minus 4x.
Thank you.
Okay, guys, please make sure we're listening to each other because I don't want to have to explain things over and over again, all right?
Okay, Zinhle, we are all yours. Sadia, we are all yours. I think Zinhle already answered. We answered her question already.
Oh.
Hi, ma'am.
Hi.
Ma'am, do you mind re-explaining question 5 because I just don't understand?
Okay, cool. So I haven't explained question 5 yet. So I'm going to do question 5 quickly and walk through it. And then guys, we do need to move on. So if you've got questions, please either put them in the chat or direct message either Yolanda or myself, and we will try and help you. All right.
Yeah.
Thank you.
Right. So question 5, we've got negative 8x plus 2 equals 18. So in question 5, the thing that I have a problem with is the fact that I've got this plus 2 on the left-hand side. And we know that we want to try and get all of the constants, so the numbers essentially over to the right. So to do that, I'm going to have to subtract 2. So essentially what I've done is I've said minus 8x plus 2 minus 2 equals 18 minus 2. Now you don't have to write this bit over here because that essentially cancels out. But what you need to bear in mind is that we're subtracting 2. Once we've subtracted the 2 from the 18, so the step over here, I get 16. And then what I need to remember is that I am trying to solve for x. So I want that x alone. Currently, that x is attached to that negative 8. So remember, this is negative 8 times x. And so in order to get rid of that negative 8, I want to divide. I need to do the opposite of multiplication. So that's what I've done over here, because negative 8 divided by negative 8 is essentially 1. So I'm just left with the x. And then positive 16 divided by negative 8 gives me that negative 2. Okay. So it's all inverse operations. This was a bit of a tricky one, so we'll do it a bit more practice. But we just need to remember, as long as we're doing the opposite of what the question originally said, you should be able to solve your equation. Okay. Okay, guys, and if you are feeling confused, I would really encourage you to go back on the website and watch the last video where we just did some basic practice of equations, okay, and just try to get some more practice through watching those. Alrighty, so if we have a look here now at example 2, these are a little bit more complex, but all we need to remember is that we're solving for x. Now, if it helps you, what you can do is you can take like a colored pen or a highlighter or a Koki or something and just sort of color in where x is, because what that tells you is that everything around x, we need to try and get rid of somehow. Now, when we have a fraction, so let's make a little note here for ourselves. When we have a fraction, we want to deal with the denominator first. Okay, now in the chat, if we have a denominator, if we have a fraction, what operation are we dealing with?
Let's go, my people. We can do this.
Okay, I see one on. Awesome, guys. Well done. We're dealing with division, right? And the reason that's an important question to ask yourself is because if you know that a fraction is originally saying division, well, then we know that the opposite is multiplication. Now, if we just need a quick reminder of what the opposite operations would be, if we have a plus, the opposite is minus, and it goes both ways. So if we have a minus, the opposite is plus. If we've got a multiplication, the opposite is division, and it goes both ways. So if we have a division, the opposite is multiplication. Okay, so we want to deal with that denominator first. Now remember, what this fraction is actually saying to me is 3x divided by 4, if we just look at the fraction. So what we want to do is we want to get rid of that denominator. Now, if that was originally divide by 4, the opposite operation is going to be times by 4. So I'm going to times the left-hand side by 4, and it's 4 over 1. I'm just putting it there to remind you that what happens here is that the 4s actually cancel each other out. The numerator is not affected. And I also need to remember that if I'm going to do that on the left, I also need to times the right-hand side by 4. Okay, what that has done for me is it has created a situation where now I've got 3x is equal to 6 times 4. Again, if you need to, feel free to do it on a calculator, but 6 times 4 is 24. Now remember, the goal is to get x alone. So if I circle or highlight where my x is, I still have that times 3. So I now need to go and do my inverse operations again and get rid of that times 3. So opposite of times is divide. And I need to remember to do that on both sides of my equation to keep my equation equal. And then 24 divided by 3 is 8. So in this case, x is equal to 8. Well done, Tando. I see your answer, Kia. Well done. Bulela, well done. Okay, guys. So if you have a fraction, the first thing we want to deal with is division. Right now, I do see some hands up. If your questions are about the last questions that we did, like I say, please either put it in the chat or direct message. But if they're about this question 1, then I'm more than happy to hear. Nice, guys. Well done. I'm seeing all your answers. That's great.
Let's go, Alenka. Oh, do you take question, Teacher Sam?
Yeah. If you guys are ready, there's question 2. You can give question 2 a try.
Yandisa, I'm all yours. You can unmute and ask your question, girl. Okay, I'm gonna move to Preen. You can unmute and ask your question.
Hello.
Uh-oh, what happened? Preen, you can ask your question.
So for question 1, how did you do the first step?
Okay, so what I saw was that I was dividing by 4. And so the opposite of division is multiplication. So I times both sides by 4, essentially to get rid of the fraction, because we don't like fractions. No one likes fractions. So we times by 4 in order to get rid of that denominator. and then I solve my equation as I have been doing.
Okay, thank you, ma'am.
Okay, good, well done.
Great. And so we're saying we are all you.
Ma'am, I didn't get the example 2 question 1 because like my brother was speaking, but they took me.
Okay, so guys, everyone listen, I'm going to explain this question again, and please make sure you're listening so that if I hopefully answer your question, you can put your hand down. All right, so question 1, we've got 3x over 4, so 3x divided by 4 equals 6. So as you can see in my little note there, when we have a fraction, we deal with the denominator first. So what that means is I now need to go and say, all right, I'm dividing by 4. If the original operation was division, the opposite is multiplication. So that's why I've gone and multiplied both sides by 4 in order to get rid of the denominator. And you can see in my next step, I no longer have a fraction because I dealt with the denominator first. So that leaves me on the left with 3x, so just the numerator. And then on the right-hand side, 6 times 4. Now 6 times 4 is 24, which led me on to my next step. And then I saw again that I've still got a coefficient to x. So I've still got a 3 in front of that x, which means that I need to go and use my inverse operations or my opposite operations and divide both sides by 3 so that I can just get that x alone, because that's all I actually want. And when I say 24 divided by 3, I get 8. And so that is my answer for x. X is equal to 8.
Okay, I hope that answered everyone's question. Guys, if you do have a question, however, please put it on the chat, okay? And Lisa, I see your smiley, lovey face. Please put it on the chat, okay? We will see the questions on the chat, okay? Because teacher Sam has to make sure that you guys understand, but at the same time, she has to make sure that you cover lots of questions so you can understand more, okay?
Okay, guys, I did ask a question about the brain break. Unfortunately, your stretch was your brain break. So if you feel you need to take a quick second, do it quickly. Otherwise, we're not going to get through enough, and I don't want to leave you not having done some stuff. All right. So if we go and have a look at question 2 now, question 2 is 4x over 5 minus 2 equals 14. All right, now we've got a little bit more going on here than what we had in question 1. So yes, we've got a fraction that I'm definitely going to have to deal with, but what I have here is a minus 2. Now, remember, these are actually 2 separate terms. And if we think back to the examples we did in the questions we did in example 1, remember I said to you, we want to get all the x's onto the left and all the constants onto the right. And so in this case, what I can do before I deal with that fraction is I can take that negative 2 and try and move it over to the right-hand side, because remember, that's a constant that I want to get on the right. I know that to do that, I have to plus 2. So my fraction will stay there. I'll deal with it in a second. 4x over 5 is equal to, excuse me, 14 plus 2, because remember, I'm moving that minus 2 over. What that does is it gives me 4x over 5 is equal to 16. And now I can start doing or dealing with that fraction scenario that I have going on there. So the first thing that we have a look at here is we see, okay, well, I first want to deal with the denominator, which is divide by 5. And so the opposite is to then times both sides by 5. Right, let's see in the question how good everyone's timetable, in the chat. What is 16 times 5? Can anyone tell me in the chat?
I'm not sure if Azandra wants to answer. Azandra, is that a question? Answer. Azandra, we are all yours while you guys are giving answers to teacher Sam.
So I got a question.
Yeah.
Why do we plus the 2 if it's a negative 2?
Sorry, can you repeat that? Why do we?
Why do we plus the 2 if it's a negative 2?
Because remember, if I want to take it over the equal sign, so if I want to move it from the left-hand side to the right-hand side, I have to use the opposite operation. So it was -2, but for me to move it, I have to now make it +2.
Oh, okay. Thank you.
Cool. Right. I'm loving these answers in the chat, guys. Well done. So exactly as all of you and most of you have said, oops, I'm now on red. 16 times 5 is 80. So we've got 4x is equal to 80. Now remember, the goal is to get this x alone. So I still need to go and deal with that times 4. Opposite is to divide both sides by 4. And remember, what you do on one side, you have to do on the other side. And then when we divide 80 by 4, we get that x is equal to 20. Well done, everyone.